This is section 2-3, part 2. So we're still talking about limit laws, and we're going to look at absolute value limits and the squeeze theorem here. So before we start, this is just a recap right here in the box. This is saying, if we look at this, the limit as x approaches some value, a, of some function is equal to L if and only if what's true. The left-hand limit has to equal the right-hand limit. Okay, and remember again, hopefully we know by now that the limit, the answer, the actual limit to a function can either be a hole in the graph, it can be a defined point, or it could be an asymptote. Okay, so moving on to absolute value. So number 8 is just saying show, it's not even saying find the limit. Show that the limit as x approaches 0 of the absolute value of x equals 0. So absolute value, we need to look at what defines absolute value. So first, over here, I'm going to define what is the absolute value of x. We've seen this before. The absolute value of x just equals itself if x is greater than or equal to 0, and it equals negative x if x is less than 0. You can think about that graphically. You can think about the absolute value of x is that v set the vertex as 0, 0. Or you can think about it with just values. So that's by definition. So now what we've really done is we've taken this absolute value of x and we've created a piecewise function for it. Okay, so the first function is x when x is greater than 0 and negative x when x is less than 0. So this problem really is saying show that the left-hand limit is going to equal the right-hand limit. Anytime you have absolute value in a limit, you're going to have to find the left side and right side separately. So first I'm going to find the limit as x approaches 0 from the left. Why am I using 0? Because that's what I'm trying to find the limit of. So from the left, this equation just becomes what? Negative x, because that's when x is less than 0. And now I can find, just by using substitution, plug 0 in, my answer is negative 0, which is 0. The limit as x approaches 0 from the right. Okay, from the right, the function is just x, and again, the answer to this is 0. So since these two are the same, then, therefore, which we can use 3 dots in a triangle, therefore, the limit as x approaches 0 of the absolute value of x equals 0. Okay, because I showed that the left side equals the right side. We do a more complicated one that's not just the absolute value of x. Next one, the limit as x approaches negative 6 of that function. So sometimes it's easiest first to define the absolute value. Okay, so the absolute value of x plus 6 is going to be itself x plus 6 when x is greater than or equal to negative 6. And it's going to be negative x plus 6 when x is less than negative 6. Okay, so it's always going to be itself when x is greater than the number that makes it equal 0, and opposite when it's less than. So now to find the limit, I need to find the left limit and the right limit. So the limit as x approaches negative 6 from the left. So from the left over here, I would use this piece. So now when I go to do the function, I have 2x plus 12, and I'm going to put in negative x plus 6 for the absolute value. Now I can simplify this, guys, just like we did last section, into what? Take a 2 out of the numerator. So I would have limit as x approaches negative 6 from the left of 2 times x plus 6 over negative x plus 6. Cancel. So my answer is just negative 2. Okay, I don't even have to substitute the negative 6 in because I'm just left with negative 2. Now if I go from the other direction, the limit as x approaches negative 6 from the right, the function would become 2x plus 12 over x plus 6. Okay, now again, if I simplify this, limit as x approaches negative 6 from the right would be 2 times x plus 6 over x plus 6, which would just equal 2. Now here, These are not the same, so therefore the limit as x approaches -6 of this function does not exist. So of what's my function, 2x plus 12 over the absolute value of x plus 6 does not exist because the left limit does not equal the right limit. Okay, next we have the squeeze theorem. So basic idea of this is if I have three different functions, so I have f, I have g, and I have h. If g is in between f and h, so I have a function that's in between f and h, then what do you guess about the limit? Well, the limit's going to be in between the limit of f and the limit of h. Okay, if you will look over here, it goes even further. The limit as x approaches a of f equals the limit as x approaches a of h, which equals L, then the middle one has to be L. So if I can show that the limit of f is 2 and the limit of h is 2, if g is in between those two, then the limit of g at the same point would have to be equal to what? Yes, 2, just meaning they would all come together. Okay, I'm going to show you just how you're going to go about showing this. Okay, how do I know that I have to use the squeeze theorem? Most of the time, the function that I'm given, x squared sine of 1 over x. Okay, first of all, I can't plug 0 in. Okay, if I plug 0 in, I get undefined. So I can't do that. And there's really no technique that we've talked about to simplify this function. I can't factor. I can't find a common denominator. Okay, so I'm going to use the squeeze theorem. The first step is to build an inequality. So, again, most of the time, it's going to be with your trig function. So the first thing I'm going to do is build an inequality with the sine part. So I'm going to, what does that mean? I'm going to say, well, what is sine in between? Sine ranges from what to what? -1 to what? 1. Okay, and even though it's sine of 1 over x, it's still going to range from -1 to 1. Okay, so that's the first step, is make an inequality. The next step is going to be to multiply this entire inequality by what I need so that I end up with the function I'm trying to find the limit of. Okay, so look over here. What's needed is the x squared. So I'm going to multiply this entire function by x squared. Or I'm sorry, this entire inequality by x squared. So what would I be? What would I get? Negative x squared is less than or equal to sine of 1 over x times x squared, which is less than or equal to x squared. So now you've literally squeezed this function in between two others. So here's my g in the middle, here's my f, and here's my h. Now if I find the limit of f and h, and they're both the same thing, then I can say the limit of the middle function is equal to that value. So now we find the limit of this one. So I'd say the limit as x approaches 0 of negative x squared. What does that equal? I can just plug the 0 in so I get 0. And the limit as x approaches 0 of this side, which is positive x squared, equals what? 0 also. Okay, since the limit of the left function and the right function both equal 0, then what must be true? The limit of this must be 0. Okay, so I can say my final statement, therefore, the limit as x approaches 0 of x squared sine of 1 over x equals 0 by the squeeze theorem. And we do need to actually write that by the squeeze theorem. Okay, so just to kind of conclude, you're always going to, first step is you're going to always start with an inequality for the squeeze theorem. So that's my first step. Second step is you're going to multiply. Third step is you're going to find the limits of the left function and the right function. And in order to use this squeeze theorem, those limits will be the same. So therefore, that's what the limit of the middle function will be.